Doesn't space travel feel like such an exhausting trip through space, where you have to spend too much time out there floating in a spacecraft? But what if there's a way to reduce the time by half to reach our neighbouring planets? With the groundbreaking development of the nuclear fusion rocket engine, we're looking at slashing the trip to Mars in half, maybe even more. That's not just speeding up current space missions, it's opening doors to explore even further out there in the cosmos. Today's Fact Me An episode is all about delving into the intricacies of the nuclear fusion rocket engine. Let's get started. Pulsar Fusion has embarked on the construction of a revolutionary nuclear fusion rocket poised to revolutionize space exploration as we know it. With this groundbreaking technology, scientists anticipate slashing travel times to Mars by half. What's even more remarkable is that this invention has the potential to accelerate exploratory missions, opening up new frontiers in our quest to unlock the mysteries of the cosmos. Pulsar Fusion. Pulsar Fusion, a UK-based company founded in 2011 by its current CEO, Richard Denan, is dedicated to providing clean space propulsion systems and services to facilitate efficient and sustainable space exploration. With a stellar team boasting unparalleled expertise and cutting-edge technology, they are poised to develop a diverse range of projects and products to propel humanity into the cosmos with confidence and ingenuity. What is nuclear fusion? Some of you might have a question. What is nuclear fusion? Well, simply put, it's essentially the sun's powerhouse replicated here on Earth. The sun and the other stars are powered by nuclear fusion reactions. To get fusion going in the sun, nuclei have to collide at temperatures around 10 million degrees Celsius. Yep, that's scorching hot. This intense heat gives them the energy needed to overcome their mutual electrical repulsion. So, once the nuclei get close enough, the attractive nuclear force between them wins out over the electrical repulsion, allowing the combining of nuclei to occur. But there's another condition. To make fusion happen, the nuclei need to be tightly packed in a confined space. That's where the sun's massive gravitational field comes into play, creating extreme pressure that provides the perfect conditions for fusion. When two nuclei combine, they release a tremendous amount of energy, and guess what? We can harness that energy to fuel our rockets. The nuclear fusion propulsion system. Okay, let's get back to the topic. Pulsar Fusion's got everyone buzzing with their mega project to build the nuclear fusion rocket. And it's not only because of the ultra speed and advanced safety of the rocket, it's about making history with the largest practical fusion rocket ever. With speeds exceeding 500,000 miles per hour and a fusion engine packed into an 8-meter-long chamber, this project is pushing the boundaries of space exploration like never before. In 2021, Pulsar Fusion achieved a major milestone with a successful experiment on heating technology. Following the creation of the initial design prototype of the fusion rocket, the project moved into its third phase, manufacturing the test unit in England. They aim to demonstrate this groundbreaking rocket in orbit by 2027, and imagine if it succeeds. It would mark the first ever nuclear fusion-based propulsion system to launch into space. Rocket propulsion systems. Chemical rockets have long been the go-to propulsion systems, utilizing either liquid or solid chemicals to generate thrust through chemical reactions. Then there are electric propulsion systems, which use electric heating or electric and magnetic fields to accelerate propellants. Compared to chemical propulsion, these electric engines are incredibly fuel efficient. However, they face a challenge. They can only accelerate a few particles of gas at a time, which limits their thrust generation. As a result, they're mainly used in deep exploration missions where long transmission times are acceptable. Now let's talk about nuclear fusion rockets. While still a theoretical concept, they're poised to revolutionize space travel, potentially surpassing the capabilities of both chemical and electric propulsion systems. According to Pulsar Fusion, the fusion propulsion concept could achieve speeds thousands of times faster than current electric propulsion systems. This means interplanetary spaceflight could be slashed to mere months, depending on the mission's destination. Imagine a rocket race where a fusion-powered rocket competes against traditional chemical rockets. The difference in speed would be staggering. development process. With such a groundbreaking concept, funding for the project came from the UK government and the UK Space Agency. Understanding the behaviour of superhot plasma poses quite a challenge, which is why Pulsar Fusion has partnered with Princeton Satellite Systems. Together, they're employing advanced artificial intelligence and machine learning techniques to analyse data. They're leveraging information from the Princeton Field Reversed Configuration Reactor to create computer simulations that predict the behaviour of superhot plasma. NASA's Orion spacecraft versus Pulsar Fusion's nuclear fusion rocket. Remember NASA's Artemis I mission? It marked a significant milestone in space exploration, with the Orion spacecraft embarking on a journey to the Moon. NASA's Deep Space Launch Vehicle showcased unprecedented power, designed to propel the rocket to speeds exceeding 17,500 miles per hour. After initiating a circular orbit around Earth, the rocket executed a translunar injection maneuver, generating nearly 25,000 units of thrust. This propelled the rocket to accelerate over 22,600 miles per hour as it journeyed towards the Moon. However, when comparing these impressive speeds to the projected velocity of the nuclear fusion rocket, which boasts a staggering 500,000 miles per hour, it's evident that the fusion rocket's capabilities far surpass those of NASA's Orion mission, exceeding its speed by more than twice. Imagine the doors Pulsar Fusion's new direct fusion drive system could open for scientific exploration. With faster and more efficient propulsion technology, scientists could delve deeper into the mysteries of Mars, conducting extensive research to uncover possibilities for human habitation. Moreover, the ability to reach distant destinations like Titan, one of Saturn's intriguing moons, could lead to groundbreaking discoveries about the potential for life beyond Earth. There is more. With enhanced propulsion capabilities, the prospect of exploring beyond our solar system becomes increasingly feasible. Who knows what hidden secrets and wonders await us in the vast expanse of the Milky Way, or even in the entire universe? If you had the chance for a ride on a nuclear fusion rocket to Mars, would you be up for the adventure? Drop your thoughts in the comments section. If you're as excited about the future of space travel as we are, hit that like button and subscribe to Fact Me In for more updates on how these technologies are developing. Thanks for watching.